Hello guys, welcome back. It's Zoctronic channel with a brand new video, and today we will convert a regular table lamp that uses one of these tubes to LED. Freaking awesome. Let's get right into the video. So, why did I decide to do this video now and LED, right? Why? Well, first of all, I had this lamp laying around for like a long time, and it was broken. The inverter inside died, the tube died, and it was just no good anymore. I didn't want to throw it out since it's a really nice design, like you can bend it and stuff, right? So good design for a table lamp, and I quite like it. So the only thing I'm left with is this broken tube, which I will throw out, and the body itself. So what we will actually do today is actually I say actually too much. So we will put a LED here, put a big ass heatsink here, we'll put a fan here to cool the LEDs down, and the whole thing will work off 120. I think that's awesome. So there are a couple main things you will need for this project if you want to make something like this. First of all, you will need some LEDs. These are 10 watt 12 volt LEDs, so that's what we will be using for this video. The second thing you will need is some sort of heatsink to actually cool the LEDs down, and since we are using a heatsink, we will use a fan to cool the heatsink down. Also, you will need some sort of power supply that you can use because they are 12 volts, so you can't just plug them into 120, right? So gotta step down voltages, and that's pretty much it. So we'll do some clever circuitry and it should work fine. So I will try to cut as much things out as I can to make this video as short as possible, but there are some things I cannot skip. So the first thing we want to do is actually wipe the heatsink so it's nice and clean. Second, you want to have your two LEDs. The LEDs will be connected in series since our power supply can help with 30 volts. So that's gonna make things more efficient, so, and give us more light. So what we will do is we just align them the way we want. I want them like this, and we just mark our holes. So we could mount our LEDs. I will only make 2 holes for each LED diagonally. That will give me good enough mounting. Okay guys, so after drilling the holes where we had marked them, now I will just tap holes. I will be using a special kind of a tap, so I just want to show you the tap I will be using. I'm not really sure what's the name for this tap, but it's much better than this kind of tap. I will just show it to you. So just so you know, if you're not familiar, this is the regular tap, and this is the one I'm using. If you guys know what's the name of this thing, I will really appreciate it. Alright, so the next step is actually to add a fan. We will be using Nidec Beta SL fan. This is a 24 volt fan. We will be using it on, well, we can actually put a regulator. I will try to use this to make it as quiet as possible. So just push it on there, really snug. There we go. So now it's on there real good. So as a easy way out, I thought I can just put that in there like that and put the fan on top, which will actually lock it. So we're gonna try that. Okay, so as you can see, we made those notches in there. Now it fits inside pretty good. So let's see if the fan will actually lock it. There you go. There. Looks like it does. So this is how the lamp will look like. Not bad at all. Not bad at all. I actually like it. If you ever wonder what it looks like to fully improvise a circuit and work it out as you solder it, this is what it looks like. A total disaster. But anyway, let me just show you what I came up with and what I have at the moment. So nothing to write home about, but this is something. So we got an LED and we got a 555 timer chip flashing the LED. Just so you know, this is actually for the flash thing for the lamp, like a standby light. So this is on. So we got a pretty clever circuitry going on there. A green LED turns on, then the blue one, and stays on for about a second, and then the blue LED starts fading down and the green one is left, so it fades down as well. Okay, so the next step is to build PWM, which will use 2 op amps. Okay guys, continuing with our disaster. Well, we actually got the oscillator working, the main oscillator, and I will show it to you in a second on the oscilloscope. Okay guys, I will show you some unbelievable stuff. Check it out. So we have our carrier wave, our main triangular wave coming out from one oscillator and then coming into buffer slash comparator, I think. Anyway, I will show you the circuit later, and this is what we're getting out. Okay, so we're getting out this. Now when we put all of that at the same time, what we end up with is actually really cool. So we are able to change our duty cycle like that. So the way that works is I have a potentiometer here that is connected to positive and negative at the same time, and the middle pin is our voltage output. So what we do is, unfortunately, I can't really do anything. I think I can do this. Okay, so there we go. I'll try to make it work. So what we do is we set the voltage like this on our sawtooth wave, and if you set it to this point, for example, the PWM would look like that. If we set it higher, like that, as you can see, it will eventually go to 0 and stay like that. So this is how, so this is how we are able to control the PWM using analog circuit like that. As you can see, that totally makes sense what I just said. You're just changing the threshold when it turns on and off. Let's say we set it here. As you can see, the voltage is about here, so this is how much duty cycle we get. We can go all the way up to 100% and all the way up to 0%. So when I put all of my channels to ground, I move my scale down, so we are at 2 volts per division, a DC coupling, 1, 2, 3, 4, 5, 10 volts. That should be enough to turn on our transistor. So what you can see at the moment is darkness, but just when I move the knob, what you will see is the little spikes on the oscilloscope down there, and when I increase it, you can see the light is getting brighter and brighter. So this is about 50%, this is 100% duty cycle. The lamp is pretty bright, like really bright. I think it's about 1000 and something lumens. I can't really claim that because I don't have the equipment to measure it, but each LED is actually 1000 lumens rated, therefore we should be pretty close to 1500, since I'm not driving the LEDs at full capacity to save them pretty much. And yeah, we have the circuit all connected up. I will show you what it looks like in a second. So you ask, where's the circuit? Well, there's no real circuit at the moment. It's just a bunch of wires in this circuit board, and we are able to change all of that goodness, brightness, with the knob, with PWM. High tech. Crap. Alright guys, it's been actually maybe 2 or 3 hours since the last time I made the video. We had done some things that are important. First of all, in terms of our lamp, we have moved our transistor to a smaller heatsink. Everything is here, so we can pretty much put a cover on here, and the top is done. So there are some wires here and there which will be hot glued. That's why the cover is not on yet, because I'm waiting for the hot glue to actually heat up. And we have our 3 wires coming out on the bottom. Now for our control circuit, what we have right now is we have our 30 volts coming in with this plug, which I'm about to demonstrate to you. You see, wires coming here, and boom, 31.47 volts coming in. This meter displays output voltage from a LM317 regulator, which is 12 volts. Don't believe me, I will show it to you with this meter. So this is the output for LM317, which is the body, 12.07 volts. Perfect. So all we have to do now is connect all these negatives and positives from these individual circuits on this prototype board and make this into a one circuit board, which will serve one main purpose: control the light. Alright guys, so what we're doing right now is I had magically marked the position of the fan. Hopefully it's gonna work. We only got one shot anyway. Okay, looks good now. So when we put it on there, we can even clamp it on. This is the final look. This is how it will look. Of course I will polish this, but okay, looks pretty good. Alright, so it's late at night right now, and I'm really trying to finish this project, doing my best. So let me just show you what we have at the moment. So the top is fully assembled, there is nothing to add, it's fully done. There will be some wires here and there, but it's a lamp anyway. It's not really meant to be pretty in terms of what I will use it for, so it's totally fine. Our circuit here is fully complete. The only thing we have changed is we excluded the 555 timer chip, since we can't use it. It causes interference with our switching oscillator, which causes these big lights to dim a little bit like that, so it's not gonna work. So I cut all connections from the power going to the 555 timer chip, so now it's disconnected and it will not work. What we will rather do is make this LED blue and connect it to power right away, so it will always stay on. That's the plan. Oh, by the way, I cut out the holes, drilled the holes for our knob and the LED, and I have connected and mounted the switch on the body, so now it's all working. We had finally come into the final stage of this project, where it's almost done. All we have to do is put the base onto the lamp, and that is it. So for extra weight, I added a transformer on there. Now it's quite a bit heavier, so that should do the trick. This is how the inside looks. A total disaster, but who cares? it's not going to be visible anyway. So what we have right now is the lamp is fully assembled. I'm just going to show you the power supply. This is a HP printer power supply. You might recognize the plug. It's a little bit modified, but that does not matter. So the lamp is off right now. You put in the plug on the back. The light comes on. You don't see it. Now you do. So the light comes on. If I pull it out, as you can see, it slowly dies. So now nothing happens. The lamp is off. Turn it on. The light comes. Pretty bright, I have to say. Alright guys, the lamp is fully complete, and let me show you what it has. Even though it's used, it looks different, and definitely we gave it a second life. So, it looks like a Frankenstein from this perspective, I know that, and it's quite a bit heavier now. But this is not the main reason why I love the lamp. First of all, the LED. I think it's freaking cool to have like a LED pilot light on your table lamp, so you will always be able to locate your table lamp no matter how dark it is in your room if it's connected. Second thing is that the fan. I did make a LED lamp before, and the problem I always had with it is it would always overheat, and eventually the driver died and I never had a chance to make one. So here I decided to include a fan so we can actually cool the heatsink, and that is really important. You might think 20 watts isn't enough to make the heatsink hot. You are wrong. It's hot. Like right now, I've been running it for about 5 minutes. Like it's hot, right? So with the fan, it will cool down much faster. So let me show you how the lamp is working. So you connect it, nothing happens. Even though you move the knob, you have your LED here. You have to push that button, and boom, now you got light. So you can adjust it to any position you want. Of course, we're adjusting the duty cycle. I think this is freaking cool. Sometimes you need like that light or like that light for reading, but if you want to look at something really small, like you need a lot of light, you do this, and boom, that's all you really need. So if you like the video, you know what to do. Leave a like down below. Also, don't forget to subscribe so we will know when a new video comes out. And let me guys know if you would like to see how a PWM works. As you can see, it's a really simple circuit to make. It only took me 1 day. No, I'm joking. It literally took me about an hour to make the circuits all together and actually test them. What actually took a lot of time is to troubleshoot, because you would always run into a problem with that prototyping board where we would end up having a little jumper between two traces with solder, and burned something, or it wouldn't work at all. So we finally got it working. It is a true PWM controlled LED table lamp. Obviously you don't have to go into such a big effort of making something like this. You can simply end up with having something like this. Turn it on, turn it off. That's all you might ever need. You don't even need a fan, or if you do need a fan, leave it on like all the time, right? So it's not for everybody. I like to have options. That's why I made this thing. It's an option to have it. It's an option to have a PWM. It's an option to have a fan and a control for it. So, it's depending on who you are, but I like to make things practical and definitely different. Thank you guys for watching, and see you next time.